All right, let's take a look at acids and bases and pH. Oh my. So the first part of the lesson is independent. So go ahead and watch these two really cool reactions of a certain acid with, in the first one, a raw egg, and in the second one with sugar. And then write down or type, what do you already know about acids, bases, and pH from any previous classes or just going through your life? And then finish with, what questions do you have about acids and bases? And then just pause the video right now so that you can do that. All right, let's take a look at the introduction here. It says acids are substances that have an excess of hydrogen ion in solution. So you can see in this picture right here on the bottom left, there's two H pluses, there's an OH minus, and there's a Cl minus. Even if you put this H with the OH, which means H2O, water, you would still have an excess of H+. Bases are substances that have an excess of hydroxide ions in solution. So you can see down here in the basic solution, we've got HOH again, but then on top of that, we've got this additional OH minus. And neutral solutions are neither an acid nor a base. They have an equal number of hydrogen and hydroxide ions. So you can see there's two hydrogen ions and there's two hydroxide ions. In this lesson, we're going to learn more about the properties of these fascinating substances. So in class, it was a PowerPoint, but you could click on that and go through it yourself, or you can watch and fill in along with the video. So first it says, Bronsted-Lowry definition of an acid is any chemical that donates a hydrogen ion in solution. So for example, HCl, when it dissolves, it breaks apart into hydrogen ion and chlorine ion. And so it is donating this H+. Bronsted-Lowry definition of a base is any chemical that accepts a hydrogen ion into their structure. So an example of a Bronsted-Lowry base would be that this NH3 accepts a hydrogen from H2O, which leaves behind the O-, OH-, and forms NH4+. And we're going to see that again written down below. So there's another type of base too. There's bases that are ionic, which means they dissolve in water into their ions. So NaOH would dissolve into Na+ and OH-. And you can see that it automatically forms this basic solution. And there is a mnemonic also to help you remember this other kind of base, the one that accepts hydrogens. And so it is bases accept, acids donate, and it means hydrogen ions. So we can put that in parentheses. So bad. Bases accept, acids donate. And then here's an example. This acid is donating a hydrogen to water, which is acting as a base. It's neither an acid nor a base, but it can act as either. And so now it's just Cl- and then H3O+, very similar to H+, that hydrogen ion in solution. And then our base here is accepting a hydrogen from H2O, so it's becoming NH4+ and leaving behind the hydroxide ion. So other terms to know, you just heard me say that H3O is basically like an H+, so that is called a hydronium ion. A hydroxide ion, just to have it in another place, is OH-. And I also said this, water can act as both an acid and a base in different situations. It is neither. So again, showing water acting as an acid, we can use our NH3 example. NH3 plus H2O water is acting as an acid because acids donate a hydrogen. And then water acting as a base would be like HCl plus H2O. This is accepting a hydrogen. Excuse me. So in this example, in number 1 here, which compound, is acting as the acid? Well, you can see acids donate, and the HBr is donating its hydrogen. And so the one acting as a base is H2O. In number 2, the SO4 2- is accepting a hydrogen, so it's acting as a base. And even though it didn't ask, H2O acts as an acid in this example. And then what happens when H3PO4 is added to water? Things that start with an H are often an acid, and this one does follow that. So it becomes H2PO4 plus H3O plus. And then this H2PO4 can actually lose another hydrogen to H2O and become HPO4 2- plus H3O plus. And for the record, this HPO4 2- can actually become, oops, I don't need an H, just PO4 3-. So that one has 3 hydrogens that it can lose. Properties of acids and bases. You probably know a lot of these already, like acids are corrosive, they have a sour taste, they contain hydrogen ions when dissolved in water, their pH is less than 7, they are electrolytes, which means they conduct electricity when they are dissolved because they form ions, and they neutralize bases. And we're going to talk more about that. There's a bunch of examples of different acids. Bases taste bitter. They're slippery. They're also electrolytes. Base plus fat makes soap. We used to make soap in chemistry class. Bases neutralize acids. They are also corrosive. And then there is also a list of some common bases. So these are things that you can find around the house a lot of times for your testing that's coming up. All right, so what's an indicator? These are substances that change color when they're exposed to an acid or a base. They can be used to identify something as an acid or a base, and even tell you how strong the acid or a base is. Different types of indicators. Litmus paper turns red in an acid, blue in a base. pH paper will turn all the colors of the rainbow, and then you can compare it to a known chart to match up and tell you what the pH is. Cabbage juice changes color in response to the concentration of hydrogen ions. Phenolphthalein is clear in an acid, and it's a beautiful pink in a base. Blueberry juice, grape juice, lots of fruits with that dark color also are natural indicators. In an acidic solution, the hydrogen ion concentration is higher than the hydroxide ion concentration. And you might guess this, but in a basic solution, the hydroxide ion concentration is higher than the hydrogen ion concentration. A neutral solution is when the concentration of the hydrogen or hydronium and hydroxide ions is exactly the same. So if you had an acid and a base, how could you make something neutral? You could add equal amounts of acid and base that have the same concentration. Is one way to do it, to make a neutral solution. Another way to do it is, let's say you had a really strong acid and a weak base. Well, you're just going to have to add a lot more base until finally it neutralizes that strong acid. So it's nice and handy if you have equal amounts of two that are the same concentration. You don't have to go slowly until you hit that neutral. pH measures the concentration of hydrogen ions, and you've probably seen pH before and talked about it in other classes. So there's a scale. It goes from 0 to 14, 7 right in the middle. 7 is neutral, and that means that it is neither an acid or a base. It's like pure water is one example. So strengthening acidity as you go from a pH of 7 down to 0, and a strengthening basicity as you go from 7 to 14. And last but not least, let's touch on acids and bases, or the strength. So if you've got a strong acid or a base, all of the molecules dissociate into ions when you put it into water. But for a weak acid or base, only some of the molecules actually dissociate. So there's not as many ions in solution. I wonder what that word was supposed to be there. There's not as many. Oh, okay. That's why it makes sense. I was going to say, how could you choose one? There's not as many hydrogen or hydroxide ions in solution. So let's do an example of a strong base, NaOH. When you put that into water, let's say you've got 3 NaOH molecules, okay? They all separate into Na plus and OH minus because, again, it's a strong base, okay? But if you've got a weak base like ammonium hydroxide, and again, let's say you've got 3 of those molecules, oops, got ahead of myself here, NH4OH, NH4OH. Okay, so you put them in water. Maybe only one of the molecules actually separates. The other 2 stay together. Again, that's the definition of a weak base in this situation. We're talking about the base and a strong base and a weak base. So strong because they all fall apart, which seems like counterintuitive. And the last couple of things in this lesson, in class, I showed grape juice, blueberry juice, and cabbage juice. I boiled red cabbage leaves and filtered out any solids. And I also had vinegar and baking soda. And so I showed how the vinegar turns all of them kind of like a hot pink color because vinegar is an acid. And then the baking soda is a base, and it turned all of them like this dark green. So then what you're supposed to do is do your own little acid-base testing at home. It's nice if you can put a picture off to the side so that I can see it as well. And then there's a really cool Phet that I want you to play around with. So click on this link, and it just has a whole bunch of really cool things that you can do in substances that you can test and then answer those questions. So thank you very much. Hopefully that helped.